Okay, so starting with the first problem, the first thing I did was draw it was a 3D cylinder, but I basically just draw the cross section of like what I imagine the sprinkler head to be like. Basically, I kind of drew like the outside of it and then draw the water inside, which is what I then labeled in purple as the control volume, and I kind of drew like the water coming out. I labeled the V1 and V2 as well as the normal forces, so then you can see whether your velocities would be positive or negative, and you'll see that later on. And then also just whether the 4 inches, which is also given in the problem. So first, I just wrote the assumptions that there would be a steady flow, gravitational forces would be neglected, viscosity neglected. And so initially what they give you is, or I wrote it as V1 was, the velocity was 30 feet per second, and so then I wrote the control volume formula and kind of made it equal to each other because they would make it inverse. And the left part of the equation went to zero, the rho dv, because it was a steady flow over time. And basically you're just left with the right hand side, which then I split into A1 and A2, which is basically just A in and A out. So I had rho of V times N dA for each part of it. And once you integrated this out, I had rho V1, or negative rho V1 A1 again, because the V1 was against the normal force, plus rho V2 A2. The rho's then canceled out, and from this point in time you need to solve for V2. So basically I isolated V2, and you need to also solve for A1 and A2 in order to put that into the equation. So that's what it did in the next two lines. Once I got those numbers, I had 30, 0.00545, 0.0349, and altogether I had the V2, or the V out, was 4.685. And so then the next part was the vertical, and the only affecting force was the intake of V in. So basically I wrote out this formula and then split it again in between A in and A out in the Y direction, obviously. And so the second part went to zero because there was no outlet in the Y direction. And then basically I wanted to solve for the total force because I wanted to solve for the pressure inside, because of the pressure inside minus the force external. And so when I put all the numbers in, then I got F external equals 21.04. And then for the radial side, I basically just said that all the forces were equal to zero because any outlet at any direction would be symmetrical to another outlet on the other direction, and basically that they would all cancel out and they would never need to be balanced because they already were balanced. So there was no forces and it would just automatically be zero. So that was it for number one. Part two, I drew the next image, and it was basically a truck, and then the actual part of the truck contained the water, and that's what I drew as the control volume. And again, like the velocity, and then how the normal forces were in relation to the velocity. So you could see the basically whether it was positive or negative. So first, the assumptions. I said that pressure and height were already accounted for through the volume, mass, no viscosity, no energy was going to enter the control volume, but it would exit as the water. Rho stayed constant because we assumed that water is incompressible. And yeah, that was it for the assumptions. And then I put out the conservation of mass formula, which I think was from like the week 5 lectures. And basically so we were doing the sum of all forces, and we had the force of friction as well as the force of water. So we knew that they would be inversely related. So that's why I solved for the force of water. Basically, we knew that the first part of it went to zero because d of dt was zero, is steady. So then we were left with the second part again, A in and A out. And it went to 0 because there was no incoming force, the A in. So then we were just left with the A out force. And from the equation before, I had that negative m was then equal to the equation. And so then these equations were the same, but I just had to add u. So it was the F of water equals negative m of u, and u was just was the velocity. So from this, I solved that F of water was negative 406.78 newtons, and it was inversely related. So that just meant that the friction was the positive of that number. Kind of similar for the second part, drew the image again. Again, the control volume was the same. However, this time we had to account for, or we were taking respect to the tanker, so it was in W this time, and the tanker, so then it was 1.8 millisecond or meters per second. Again, kind of doing the same equation. Most of the thing that's different is just because it was momentum. And yeah, so then the left part of the equation again went to 0 because there was no intake. And with when summing the forces, I inversely related friction and water, basically did the exact math again and ended up with friction equaling 254.33.